this lesson, we're going to be talking about perpendicular lines. By the end of this lesson, you should be able to identify properties of perpendicular lines and write the equation of a line given a point and a perpendicular line. If we examine the following pairs of lines below, what you'll notice is a common theme. You'll see that these lines all intersect. And if you look at them at the right angle, and if we had tools to measure, what you would also be able to identify is that all of these lines intersect to make right angles. And so what this means for us is that these lines, because they intersect to make 90-degree angles, are perpendicular. Now, I want to note that you can't just look at a pair of lines and say that they are perpendicular. You actually have to have proof. So you'd either have to measure them or you'd have to know properties about the lines on the coordinate plane to prove that they are perpendicular. So let's take a look at that. So let's look at their equations. We know that these lines are perpendicular, and so let's look at the equations to see if we can come up with some conjectures here. So if we're looking at the equations, what we want to look at is we want to start by examining the slope, and we want to also examine their y-intercepts to see if there's any commonalities, any similarities, any differences, or anything, any patterns that we can pick up on. So if we look at their slopes, we see that for pair 1, the slopes are 2, or 2 over 1, and negative 1/2. And for pair 2, we see that the slopes are 4, or 4 over 1, and negative 1/4. And for pair 3, we see that the slopes are negative 3, or 1 over 3. So we're looking at the slopes. And what you might notice is that the slopes are reciprocals. If we had 2 over 1, now it's 1 over 2. If we had 4 over 1, now it's 1 over 4. And if we had 3 over 1, now it's 1 over 3. So we notice that the slopes are reciprocals. And not only are they reciprocals, but they're also opposites of each other. So we see 2 over 1 is now negative 1 over 2. 4 over 1 is now negative 1 over 4. Negative 3 over 1 is now positive 1 over 3. So what we can examine from their slopes is that their slopes are opposite reciprocals of one another. If we look at their y-intercepts, we see that for this first one, the y-intercepts are at the origin, or at 0, 0. Because they're not written there, we know that it's at 0. So their y-intercepts are the same. If we look at pair 2, their y-intercepts are also at the origin, so their y-intercepts are also the same. And if we look at pair 3, we see that one has a y-intercept of 5, we see that one has a y-intercept of negative 1, but we still know that they're perpendicular. And so the conclusion that we can draw from their y-intercepts is that the y-intercepts really don't matter in this case for perpendicular lines. They mattered yesterday when we talked about parallel lines, but they do not matter when we talk about perpendicular. What matters with perpendicular lines is that their slopes are opposite reciprocals of one another. Okay, so just to recap, perpendicular lines are lines that intersect at right angles. They make 90-degree angles. The symbol for a perpendicular line looks like an upside-down T. When we talk about the things from the coordinate plane, the biggest pieces that we want to take away from here is that their slopes are opposite reciprocals. And you can check to make sure that their slopes are opposite reciprocals by multiplying them together. When you do this, their product will always equal negative 1. And then just a side note here is that all horizontal and vertical lines will always be perpendicular to each other. Okay, so when we're looking at equations and we're trying to determine if they're parallel or perpendicular, you want to look at their slopes and their y-intercepts to justify your answers. So in order to do this, we're going to need to make sure that we're in slope-intercept form so that we can identify the slope. So we're going to have to change the equations that are not already in slope-intercept form into slope-intercept form. So if we look at the first equation, if we look at negative x plus 3y equals 1, and we change this, remember that we're going to get everything away from y, so we'd start by adding x to both sides. That's going to move the x over. So what we have is 3y is equal to x plus 1. And then the last step would be to divide by 3, divide by the coefficient. And so this would give us y equals x divided by 3 is 1/3 x plus 1/3. So here's our first equation. Line B is already in slope-intercept form, so all we have left to do is to change line C. So we have 2x minus 6y is equal to 4. Again, subtract the 2x on both sides, get rid of the x's first. That gives me negative 6y is equal to negative 2x plus 4. Notice I always put the x variable in front because that's how it's written in slope-intercept form. Divide everything by negative 6. Y is equal to negative 2 over negative 6 is 1/3. X minus 2/3. And so here is our equation in slope-intercept form for that one. And now we can begin to look at lines that are parallel and perpendicular. Remember, parallel means that lines have the same slope. So if we look at line A and at line C, they have the same slope. And notice that one has a y-intercept of 1/3, one has a y-intercept of 2/3, so they also have a different y-intercept. So that's what we want for that. So for parallel lines, our parallel lines are A and C. Now for perpendicular lines, remember that their slopes are opposite reciprocals. And so if we look at 1/3 and negative 3 over 1, those are reciprocals. They are opposite reciprocals of each other. So what this would tell me is that line A and B are perpendicular, and line B and C are perpendicular. So A and B and C. Again, in order to determine, we want to look at their slopes. In addition to being able to determine perpendicular and parallel lines, we want to be able to write equations when we're given those. So if we're looking at this first one, we know that we have a line that passes through the point 1, 1. So that's information that's going to be valuable to us and is perpendicular to the line y equals 1/4 x plus 6. And so what this tells me is that my line, if it's perpendicular to this, will have a slope that is the opposite reciprocal to 1/4. And so this would change it to 4 over 1 if I take the reciprocal. And the opposite of a positive is a negative, so my slope for this line would be negative 4 over 1, or just negative 4. Now that I have the slope and I have the y-intercept, we can begin to write the equation. We don't know the y-intercept, and so we're going to have to solve for it. So what I can do is I can take y equals mx plus b. I can take slope-intercept form, and I can substitute in the values that we know. So I can substitute in the point, I can put my slope in, and we can solve for b. So my x and my y are 1 and 1. Remember that my slope is negative 4. And so we have negative 4 times negative 1, which is negative 4, plus b equals 1. Add 4 on both sides, and we get b is equal to 5. And so what this does for me is it gives me my y-intercept, and so now I can write my equation, which would be y equals negative 4x, that's my slope, plus b. No, plus 5, there we go, because we solved for it. Okay, similar to the last one, now we're going to use point slope form. We know that it's going to go through the point 4, 3. I know it's perpendicular to this line, so my slope has to be the opposite reciprocal of 4, or 4 over 1. So a positive would make it a negative. 4 over 1 would change to negative 1/4. And so my slope for my line is negative 1/4. If I'm using point slope form, we're substituting in the values into this y minus y1 equals m times x minus x1. So y minus 3 equals negative 1/4 x minus 4. Distribute, so y minus 3 equals negative 1/4 x plus 1. Multiply the fraction by the top, so negative 1 times negative 4. and then divide by the denominator. And then add 3 on both sides. This gives me y equals negative 1/4 x plus 4. And what I like about point-slope form is that once I've changed it, I'm done. The equation's already written for us, so we don't have to go back and rewrite it. Looking at one more, we see that we have an equation. We want to write an equation. We can pick either method that we want. We know that our point passes through the point 2, 1, and is perpendicular to the line that's graphed. So I need the slope from this line. The slope would be positive 2/3 for this line. So my line would be the opposite reciprocal. So if it was 2/3 for this line, my slope would be 3/2. If it was positive, my slope will be negative. So the slope of my line is negative 3/2. I'm going to use point-slope form. So using point-slope form, I plug in my points. I write my slope. And we distribute the slope, and I'm going to change it to slope-intercept. We distribute the slope, so this will be negative 3/2x plus 2 plus 3. And then y minus 1. And then add 1 on both sides, and we get y is equal to negative 3/2x plus 4. Again, remember that when we're looking at perpendicular lines, we're not using the same slope, but we need the slope so that we can take the opposite reciprocal of it. Before watching the next video, I would encourage you to reflect on the following statement. To write an equation of a line when given a point and a line perpendicular, what would you do? All right, as usual, please subscribe to the channel so you get updates as new videos are released. Thank you for watching.